Okay, so today we're going to talk about finding minimum and maximum values. And this is actually pretty easy because all we're doing is finding the y value of the vertex. And we just found the y value of the vertex when we did these two problems here. We found the x value for the vertex when we found the axis of symmetry. And we found the y value of the vertex just by plugging that x value in to the function. So this is really something that's pretty easy to do. When the parabola opens upward, it has a minimum value. When it opens downward, it has a maximum value. In all these problems, the domain is all real numbers. But when we start talking about the range then, if it has a minimum, then the range is y is greater than or equal to that y value of the vertex, or the minimum. And the range for those that open downwards is y is less than or equal to the value of k, or the y value for the vertex. So if they ask you about domain and range, domain is always all real numbers for parabolas. In the range, if it has a minimum, y is greater than or equal to that value of k. If it has a maximum, y is less than or equal to that value of k. So where we've used h and k before, we're using k again here. That same exact k, just like the one we used in lesson 1. So they want us to find the min or max values and state the domain and range. Now, notice this caution here. This is very important that you notice this. Okay? The minimum or maximum value is the y value of the vertex. It's not the ordered pair. Okay? So when you're stating the min or the max, you are just telling me what the y value is. You're not putting x and y, you're just putting y. Okay, so all you care about is the value of k, right? We're talking about k. We're talking about the vertex, so we're talking about the value of k. So here we have negative 3x squared plus 2x minus 4, and they want us to find the min or the max. So first of all, does this open upwards or downwards? Okay. If it opens down, that means it has a maximum. Right? So when we write the domain and range for this, then we're going to be using this here. The domain will be all real numbers, and the range will be y is less than or equal to whatever that value of k is, whatever that maximum number is. So how do we find it? We find it just like we found the vertex for any standard or any quadratic function in standard form. To find the x value, we'll do negative b over 2a. And then to find the y value, we'll plug that in for x in the function. So this is negative 2 over negative 6, which is 1/3. Okay? So the x value is 1/3. Well, that's nice, but now I have to use that value then to find the y value for the max. So in this case then, the max is going to equal negative 3 times 1/3 squared plus 2 times 1/3 minus 4. And that's our value of k also from when we were talking about the vertex. This was the value of h. This y value is the value of k. Now, you guys have calculators that does fractions, right? All right. You shouldn't even need one that does fractions because this one, when you simplify it, it should be the decimal number you get should be a number that you could convert to a fraction. So negative 1/3 plus 2/3 is 1/3, and 1/3 minus 4 is negative 3 and 2/3. So the maximum equals negative 3 and 2/3. So the domain is all real numbers, always for a quadratic function. And the range in this case, because it opens downward, y is less than or equal to negative 3 and 2/3. The value of k. Because we found the vertex, what we did is we found the vertex. Okay? The x value for the vertex, 1/3. The y value, negative 3 and 2/3. So my maximum is negative 3 and 2/3. That y value, the range is less than or equal, y is less than or equal to that y value. Nathan. Negative 1/3 plus 2/3 is 1/3. When I take a 1/3 away, I get 3 and 2/3. Okay. What? Negative? Oh, what? Minimum. Minimum. Well, there can't be a minimum here because the graph looks like that, so it only has a maximum. Okay? If it opens up, then it has a minimum. Okay? All right, so let's look at one other example. Okay? This one, though, happens to be a word problem. Right? So we're going to challenge 40s reading English. Okay, the average height in centimeters of a certain type of grain can be modeled by this function, where r is the distance in centimeters between the rows in which the grain is planted. Based on this model, what is the minimum average height of the grain, and what is the row spacing that results in this height? So in this case, they want us to find r and h, right? Okay. So they want to find the minimum. How do we find the minimum? How do we find the minimum? It's h, right? In this case, it's h, the height, right? But if we're talking about the vertex, we're talking about k. So first thing I have to do is I have to find the value of x before I can find the value of k. So we know that x equals negative b over 2a, same thing. So in this case, b is what? Okay, negative 1.28, and I'm going to divide that by, oops, we have a minus there. We're going to divide that by 2 times 0.024. So I have 2 negatives, so I have a positive 1.28 divided by 0.048, which equals what? What is it? 26.666? Oh, okay. 26.67. All right, let's use that. Okay. So now, to find the minimum, all right, I'll put 26.67, or your calculator. Let's talk about the use of our calculator then for a moment to help us out with this. Okay. So 1.28 divided by 0.048 equals that number there, right? So if I want my answer to be the most accurate it can be, I will do 0.024 times, and how do I get this number here? Okay. Well, you don't have to go up and use it. You can press second and then the negative key, okay, the answer, ANS, okay? And then I can square that, put minus 1.28 times the answer, and then plus 33.6. And we get 16.53. Okay. So our minimum in this case is 16.53 what? What are the units to go with this? This is a word problem. So what? Centimeters. Okay. So the average height in centimeters of a certain type of grain can be modeled by this function. So r is the distance in centimeters between the rows. Based on this model, what is the minimum average height of the grain? So the minimum average height is 16.53 centimeters. And what's the row spacing? What's the row spacing then? We already know it. 26.67. Because r is the first number we found is actually r, because that's row spacing. Okay. So instead of using x, our function has r in it, and r, it says, is the distance between the rows. So the row spacing is 26.67 centimeters. In other words, to get the minimum, they have to have average spacing of almost 27 centimeters. Okay. Any questions about that?